Good afternoon, all and all present here. Myself, Dr. P. Janagaratnam, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the planar mechanisms and what are the basic types of slider crank mechanisms and single and doubler slider crank mechanism. Today, I am going to discuss about the new topics which is related to the four-bar mechanism. This is also comes under the category of one kind of planar mechanisms and basic fundamentals and key concepts and applications of four-bar mechanism. So four-bar mechanism basically it consists of four links, base and crank and connecting rod and lever. Finally, it will be connected to the any of the slider. The again it will be produce some of the linear motions which will be used in the different applications like locomotive and other IC engine applications. So first of all, what is meant by four-bar mechanism? It is the simplest movable closed chain linkage and four rigid bars connected by four revolute pairs and converts motion and forces in the machines and 1 degrees of freedom, which means moving one bar fully determine all these kind of links. So this is the general components of four-bar linkages like grouped link, which means ground link, fixed frame of the mechanisms, which will be fixed under the ground. And second one is crank input links. We have to give the input speed, which rotates fully or oscillates based on their crank rotations, and the coupler or otherwise the connecting rod will be moved through the directions. And the next one is the follower. These are all the basic components of four-bar mechanisms or four-bar linkage. And this is the simple motions crank which will rotates up to 0 to 360 degree, and the rocker which link oscillates between the two angles. The mechanism types are crank, double crank, and double rocker mechanisms. So this is the some of the applications which will be used in that different aerospace industry. So this is the Grashof's rules, which will be applied for making these kind of four-bar mechanisms. So S plus L, which is greater than or equal to P plus Q. Shortest links and longest links, and P and Q are the different length of these other two links. So it determines the mechanisms of crank rocker and double crank or double slider crank mechanisms, which are all the different inversions of planar mechanisms. So next one is for this is the Grashof rule. So here the calculation shows that this is the double slider crank mechanism. So interactive models allow changing lengths to see the motion of different links, as well as the understanding this relationship is the key and main focus of designing these kind of four-bar linkages. So link of the 5, 7, 8, 9, which means all these four-bar link motions will be determined by using this kind of visualizing these kind of Grashof's law or rule. So this is the kinematic analysis and functions generations. First ones we have to give the set the input and output angles. So input angle, which means the crank will rotate up to 0 to 360 degree up to n the RPM. We have to give the speed, and the based on their input link the other couple curves and other the input motions and output motions, all these kind of motions will be analyzed. So based on their analysis only, we have to construct the velocity and acceleration diagram. How we are calculating the velocity means the range of the rate of change of time with respect to the rate of change of displacement with respect to times, which will be calculated by using this kind of velocity. The rate of change of velocity with respect to time, which will be calculated by using this acceleration. Once we have to construct the free body diagram or the space diagram. From that space diagram we have to construct the velocity and acceleration diagram. From that we have to find out any kind of velocity or accelerations of that kind of difference. So this is the some of the practical applications of four-bar mechanisms like in our automobile sectors and robotic systems also, and the other ladders, chairs, and other compound and other gear trains, and that Taylor box in available in that tractors. So here all these are kind of real-time practical applications of four-bar mechanisms. So this all these kind of functions will be used in that agriculturals and automobiles and different mechanical sectors. So this is the advantages and some of these designs considerations. Advantages means it is the very compact and simple and predictable motions. Already we have to predict that, and oriented control. Other design considerations means we have to consider the space constraints and travel limits and other materials. These are all the some of the designs considerations while we have to consider for designing this kind of four bar mechanisms. And this is the conclusions why we are going for an four bar mechanisms, like foundations of designs fundamental is very strong, and we have to give the clarity of motions and different types of motions. Controlling mechanical inputs are given, and it is efficient when compared to the other planar mechanisms, and understanding of key concepts is very easy. And these are all the reasons why we have to select this kind of four bar mechanisms. So this is the summary of today's class, like linkage mechanisms and types of four bars, and what are all the key definitions and applications discussed. And this is the assessment questions according to the stability and analysis of alpha value, which is equal to 0. According to the Grashof's law, it can be determined. A robotic arm fixed at its base and having the tool and its free end is a prime example of which type of kinematic change, which means the open type change. These are all the some of the reference I have to choose and for making this kind of PPT and lecture. So thank you. In our next video series, I have to discuss about the another one more interesting topics which is related to the mechanics of machines. Thank you.